MCA Prep Packet, Day 6. Our first benchmark is on page 13 in your packet. Use linear functions to represent relationships in which changing the input variable by some amount leads to a change in the output variable that is a constant times that amount. Number 1 says let y equals 7x plus 3. The value of x changes by 1 in part A from 2 to 3. By how much does the value of y change? So our input variable, input is x. So we're going to change our input variable, x, by 1. And then we are going to determine what effect that has on our output variable, which is y. So, y equals 7 times 2 plus 3, because they want me to use 2 and then change it to 3. And then y equals 7 times 3 plus 3. So the value of x at 2, 7 times 2 is 14 plus 3. So the y value would be 17 when x equals 2. The y value when x equals 3 would be 21 plus 3, which is 24. So I could say that when the value of x changes by 1, so when x changes by 1, y changes by 7, from 17 to 24. Now part B says the value of x changes by 6, from 2 to 8, from 2 to 8. So when y, so let's say when x is 2, we already solved this one. So that was 14 plus 3, or 17. Then we need to change x to 8. So now it's 7 times 8 plus 3. So that would be 56 plus 3, which is 59. So how much does the value of y change now? When x changes by 6, y changes by 42. From 17 to 59 was an increase of 42. So what you should notice is that in the equation y equals 7x plus 3, x was being multiplied by 7. So what happens is when x changed by 1, y changed by 7 times 1, or 7. And when x changed by 6, y changed by 7 times 6, or 42. Because that constant 7 was being multiplied by x each time. Our next benchmark can be found on page 39. 8243 says express linear equations in slope-intercept, point-slope, and standard forms, and convert between these forms. Given sufficient information, find an equation of a line. Well, slope-intercept is y equals mx plus b. Point-slope is y minus y1 equals m times x minus x1. And standard form is the trickiest one of all. Ax plus by equals c. And remember, a, b, and c have to be integers. So that means no fractions, no decimals. So no fraction, no decimal. And a must be positive. That's another rule. A must be positive. Okay, so the first one says that we need to write the equation of the line in point-slope form. The slope, or m, is 2/3, and the point that is on the line, that would be our x-coordinate, x1, and y-coordinate, y1. So I'm going to use this point-slope form right here and plug in those numbers. So I start with y minus, and then I need to plug in my y coordinate from the point. So that would be -3 equals, then I put my slope in for m, and then x minus my x coordinate from my point, which is 4. The only thing to do to simplify is to take the y minus -3 and turn that into a plus. Subtracting a negative turns into a positive. So this is my equation in point slope form. Now the tough part. We are going to take this point slope form and we are going to turn it into standard form. Standard form. So to turn this into standard form, I am going to need to get rid of the parentheses because the parentheses you do not see in standard form. So I'm going to distribute by 2/3. That will give me y plus 3 equals 2/3 x minus 8/3. Remember that 2/3 times -4, I can put a 1 under it, you multiply straight across, so it would be -8/3. Now, in standard form, since I can't have any fractions, I'm going to need to multiply this entire equation by 3 because that will eliminate my fractions. 3 times y and so on, like that. So 3 times y is 3y, plus 3 times 3 is 9, and then 3 times 2/3 x, if I put a 1 under it, my 3's cancel out. So I just get 2, so 2x. And then my 3, or 3/1, if I multiply it by the -8/3, again the 3's cancel out, and I just get -8. So 2x minus 8. Now, my terms have to be in a specific order in order to be in standard form. I need the x and y on the left-hand side and then the plain number c on the right-hand side. So I'm going to subtract this 9 on both sides because I cannot have a constant 9 on the left-hand side. And then I'm going to move my 2x. So I'm going to subtract 2x on both sides because 2x is supposed to be starting us out over here. So now I've got -2x plus 3y equals 17. Oh, -17. Okay. Now the only issue left is that first term, x, actually has to be positive. So you may remember from when we were working with systems that if we multiply by -1 now, to get the final answer over here, it would be positive 2x minus 3y equals positive 17. So standard form has a lot of picky rules that you have to follow about the order and about the type of numbers that are allowed. So it took a lot of manipulating for me to get from point slope into standard form. Converting out of standard form is a lot easier to go from standard to slope intercept. Okay, my last benchmark for today, 8247 and 8248, I guess, represent relationships in various contexts using systems of linear equations. Solve systems of linear equations in 2 variables, symbolically, graphically, and numerically. And then 8248, understand that a system of linear equations may have no solution, one solution, or an infinite number of solutions. Relate the number of solutions to pairs of lines that are intersecting, parallel, or identical. So I'm going to go like this. No solution, that's parallel. One solution is intersecting. And then we had an infinite number of solutions, and that was when our lines were identical. Our lines were identical. So no solution was parallel. One solution was intersecting. And then an infinite number of solutions, identical. Check whether a pair of numbers satisfies a system of two linear equations and two unknowns by substituting the numbers in both equations. Okay, so consider the following lines. Which two lines are parallel? Which two lines are parallel? Well, we could graph all of these, and that would probably be helpful. I'm going to start with line number 1, I'm going to have in red. So line number 1, 4x plus 3y minus 6 equals 0. To graph this, I need to have y by itself. So I can subtract 4x on both sides. 3y minus 6 equals negative 4x. And then I would have to add 6. 3y equals negative 4x plus 6. And then divide by 3. So what I'm doing is I'm getting this equation in slope-intercept form, so the y is by itself. So my slope is negative 4/3, and my intercept is 2. So that line is ready to graph. My second line will graph in blue. That's ready to graph already because it's in slope-intercept form. And then my third one, I will go with green for this one. So 4x plus 2y minus 8 equals 2. Subtract 4x on both sides. So 2y minus 8 equals negative 4x plus 2. Add 8 on both sides. And again, I'm just trying to get the y by itself. So negative 4x plus 10. And last, divide by 2. And make sure you divide everything by 2. So I get negative 2x plus 5. Okay, so we'll graph that one in green. So what I need to do is I'm going to write these equations over here so that I know what my new equations are. So my red one is negative 4/3 x plus 2. And then my green one is negative 2x plus 5. So now I can erase my work. Whoops. I don't want to do that. Okay. I can erase my work over here, and then we will be able to draw the graph in this space. And then we can answer our questions. So my red line starts at 2 and goes down 4/3, like this. Okay. My blue line starts at 4 and goes down 2/1, like this. Okay, and my green line, negative 2x plus 5, is just above that blue line, because the slope is still negative 2. It's just starting out one higher, so you should be able to tell that those are the two lines that are parallel. So the ones that are parallel were my blue and green, so 2 and 3 are parallel. They have the same slope. And then which two lines intersect at 3, -2? At 3, -2, write 3 down 2 was my red line and my green line. So, my red line and my blue line. So that was 1 and 2. 1 and 2. So the red line and the blue line both go through that point 3, -2. That's where they intersect. Okay, you are ready to finish those pages now?